I'll start with the question. How many of you have heard about OPA? How many of you worked with OPA? Okay, so we know where we are. Okay, so let me start with what you're gonna benefit from this talk. So first, I wanna tell you about two parts of this talk. First would be about Gatekeeper, so how we can do something like, I don't want any deployments or pods without, in case for deployments or pods labels. So we want our deployments to have all required labels we defined. Or maybe you want prevent anyone applying a pod without resources limits or requests. How can you do this? Maybe you want to whitelist your images that can be applied to your cluster. Second part would be a little different, because the first one is more or less for a Kubernetes admin, but the second one also will be focusing on OPA, but completely different scenario, completely different use case. And of course, it's microservices. So we will build very scalable security mechanism. So we offload all decisions to central place, but we'll still benefit from microservices. All right. Oh, by the way, at the end, you will have the link to the repository. During this talk, I'll be using Kubernetes cluster deployed on DigitalOcean. And both cases are there. You can check the code, apply it yourself, and work with OPA. Okay? So a few words about me. My name is Piotr. I used to be Java developer, Node.js developer. For a couple of years, I've been a DevOps, and something went wrong. Okay, you're back. And for a couple of years, I worked with cloud, especially AWS, and lately Kubernetes. So when you bring it all together, put it in a blender, you get this funny name, cloud native engineer or developer, whatever you want. This is me. So what is OPA? All right, what is OPA? So this is from their site. OPA is a full-featured policy engine that offloads policy decisions from your service. What exactly does it mean? Basically, you just don't care about making decisions. You want someone else to make a decision, and you act upon this. We'll see this in examples. How OPA works. So the OPA, basically it's a Golang library or binary. You can use it in two ways. Most people I think is binary, very small one, and it uses two main components: policies written in Rego file, Rego language, very odd. I won't be focusing on Rego much here during this talk because it would take a long time. But if you like OPA, play with Rego. I give you my word, it will be fun. Okay, the second part are data files. So in policies, we'll see them in a minute. We define rules, but data files are just JSON files that provide some data, nothing else. Very simple JSON objects. And what else OPA does, it exposes REST API, very easy to integrate with, so it's very flexible. Let's see something like sample policy. So this is a policy on the right side. So you see that there is a package, so every rules are contained in a namespace. This policy is a trivial one. So what we see here is that we expect that input name equals John. But what input is? So when we run OPA, we provide these rules in Rego files. We provide data, and to make a decision, some service needs to provide this input, some kind of a context to make a decision. So in this file, sample Rego, we see two rules, hello, the same name, but at least one has to be true. So the first rule means that we expect a name from the input to equal John and city from the input to equal Warsaw. The second rule, also named hello, we expect input name to equal Mark and city to equal Krakow. And down there is this example of input object. We see here that the name of the person is John and he comes from Krakow. So none of these rules will be true, because John should be from Warsaw and Mark should be from Krakow. And here John is from Krakow. So, and believe me, this is very trivial rule, very trivial Rego file. They can be much more complicated, but very, very powerful. Data files. Because you don't want to put you don't want to hardcode any value in the Rego file, you can use data files. So here is the same example, but we're using data files. So we have a data JSON, which describes people and their location, and exactly the same or similar Rego file, which expects employee name to be employee name and city to be to matching the same entry from data JSON. So this in square brackets we see letter, and in these two lines where we have name and C, this is the same employee. So the same employee has to have a name equal to John and city to Warsaw, or the other person name Mark and city Krakow. So they should match. But I really do not want to focus on Rego here because it's very strange. That was my experience. But when after some time, it gets much easier. I want you to convince using OPA and show you what are the ways to use it and why it is useful. Right. So the REST API, how we can integrate with it. Here you can see a sample curl request. So when you run OPA, you loaded all Rego files and JSON objects. You just fire this request and provide input. Very, very simple post request. And you get this response, like in a bold result, true and false. These are the same examples from the previous slides. So for integration, very easy. But since it's difficult, can we test it? So you build these rules and you need to be sure that what you defined is correct. And there is a way, of course, to test it. So to write a test, you just write another Rego file, but this time you need to prefix the rules with the test and file with test as well. And on the top, you see that we can test our rule, which is named allow, and we expect in the first test rule allow to be true. In the second one, we expect allow to be false, so not allow, and up there allow, and we can mock input, so you don't need to add this JSON files for tests. You can mock it, provide different data. To run it, you just fire OPA test, and I have 2 policies. And this directory test rego files should be present. Very, very easy. I'll show you how to make it even easier with Visual Studio Code. There's a very nice plugin for that. Just press the shortkey and everything goes well. All right, so enough of Rego. So the first use case. So how many of you are working on with Kubernetes or Kubernetes admins? Not that many? Okay. There are a few people. All right, so let's say you're a master of your Kubernetes cluster and you don't want anyone to mess with it. You don't want anyone to break your rules, and maybe you just want to have some standards applied so that you could maybe build some better metrics, some better Grafana dashboards, etc. Because everyone has to comply to some standards. So, you decide, right? So you're a master of a cluster. So maybe it's just that you want to allow some images, but from my own registry. I don't want any other registries. I trust only mine. Or maybe it's you're scared of having pods without any resource limits or requests. It can go bad. So yeah, no one is allowed to add pods without these fields. Or naming strategy, like, okay, we like it. Actually, at least I like it. So everything is nicely shaped. We can filter, we can organize everything. We can clearly see who is responsible for a certain thing. So this can be done with the Gatekeeper. Gatekeeper is a tool, quite new. It uses admission web controller webhooks, so it reviews the all manifest which comes to Kubernetes and can do something about it. In our case, it will just check whether manifests are compliant or not. And what does it mean if they're okay or not? You need to define it, because this is your cluster, these are your rules. You need to define rules the way you want. So, Gatekeeper uses CRDs, and of course Open Policy Agent, but it's built in. So, because Gatekeeper is also a Golang application. How do you install Gatekeeper? As usually in kubectl apply, and everything works, right? So what it will create, it's a stateful set. By default, it will create cluster roles, bindings, custom resource definition, because these constraints which we will create are CRDs. There is a default config. This is useful for syncing data. So Gatekeeper can sync data from Kubernetes, like all pods that are running locally, so that you can build better policies. And finally, it will just create service. Okay, so there are two major components of a Gatekeeper. The first one is Constraint Template. So the first part, you could clearly recognize this is some manifest, some resource in Kubernetes. This is CRD, right? But down there is a rego, and here it gets complicated. So you need to know rego to build these policies, but actually they can be quite small. So, and rego is fun, believe me. Okay, so what do we have here? there are parameters. So we define a template for future constraints. So here we're saying that our constraint will need properties like labels, because in this Rego policy we will expect all deployments to have a list of labels. So these are the labels I want all deployments to have. So future constraint will need to provide the labels are required. So we're not hard coding it here. And the Rego part. So violation. This is the Rego rule. If it returns something, then deployment won't be applied. All right. So just a small story pointer here. Okay, much better. All right. Oh, it's working. So here is our input. Review object that comes from webhooks, and this is the object. In our case, it would be deployment, and we check the labels. This line in Rego means that we will aggregate all label keys, so not values, because we are not checking values, but only keys. And these are provided keys in for labels. The same we do for required, but now we're referring to parameters which will be provided in a constraint. Little of math, and if there are more missing than 0, then we return violation. So let's see how exactly constraint could look like. Right? Here is this implementation of the previous constraint template. Much better, right? Much easier to read. So the constraints name required labels. These were defined in the constraint template. Here we can select resources we want to check, and these are parameters. Actually, these labels are the recommended one by Google. So this is how we apply it. Luckily, we can build a repository with constraint templates. So actually, you can share these templates as an open source rules, and actually you don't have to deal with Rego. Right? All right. Almost there, because I just seen a demo. Okay, so test it. Can we test these rules? So yes, of course, because it's Rego, and I'll show you. This is how you write test, exactly the same way I showed before. Test, listing labels, and here we count number of violations. And we provide also our rules. So for testing, we just extract this Rego definition and write another Rego to test. The never-ending story of microservices. Maybe we can create another one. Maybe we could use OPA for this use case. So since OPA can make decisions, we can offload them from all microservices to OPA. So don't make any decision. Let's see how we used to think about decisions in applications. All right. So these are two examples which are quite familiar to me from Java and Node.js. So this is a very typical Spring way to check the role of the person invoking some method. So if person has an admin role, he will be able to invoke this method. The second example is from Node.js, very similar. If someone has role writer, he can do something. Right, and we have so many microservices, and we need to create another role, right? Maybe this is a quite complex situation. There are plenty of roles, and do we want to hard code each of them in the code? And the rules are changing, and we need to redeploy again our microservice because something has changed. So, what is the place for OPA here? We can run OPA as a sidecar in each microservice. So in a pod, right? We can connect to this OPA on localhost because it is a pod. Let's say it would be nice if the microservice sent a whole context, which is required to make a decision to OPA. And actually, I had this problem some time ago, and I came up with this idea of having principal, resource, and action in this input object going to OPA. And I think it's very familiar to you because you recognize the principal, action, and the resource. So that comes from IAM policies. So with these three fields, you can clearly say who is doing performing the action, so the principal, what is being changed, and how it's being changed. So the whole context of the action. Okay? All right, so these are our microservices. Each of them has a OPA sidecar. They can be scaled because these are pods, right? So every pod will have this OPA sidecar. And yes, and repository. This is my naming. So because there will be so many of them, these microservices, we want to have an easy way to control policies and update them. So we do it this way. We will configure these OPA sidecars to pull policies from the central place. So, for example, every 30 seconds, each of so every 30 seconds, each of OPA sidecar will pull Rego files and data from the central place. Okay. Let's make it more fancy. Okay, we have this sidecar, and it's very nice to have this OpenID offer. There is definitely something wrong with that. So OpenID and JWT tokens, very, very popular lately. Yeah, let's use it. So let's say each microservice is a resource server. So it expects JWT token in incoming request in authorization header, and let's use this JWT token as a principal. So we want we'll just check in each microservice if the JWT token is signed, and to make a decision, we'll send JWT token, action, and resource to OPA. Right, so here is the example of how we can configure this synchronization. So we have this policy repository, and here we say that this config file is mounted to each OPA sidecar. And by this config file, we're telling OPA to pull a bundle from the central place. So it's host name. In my demo, it will be Nginx serving this bundle. And these are just times how often it should pull it. Very, very simple way. So central place with bundles, sidecars, and they're constantly pulling actually up-to-date policies. Okay, so these these are my custom policies. So not Rego files, but in this actual real example, I wanted to avoid writing Rego files, so because people will not understand, like business people will not understand Rego, right? Because it's very complex. But with this specification, with this having this standard, it's very easy to define what is allowed and what is not. And here's the link to my GitHub. There is a much more complex example of how we can build these AM policies. For this case, there are Rego files for exactly this need. But are there any questions? Let me just switch to presentation. Oh, it's demo time.
Okay, we've got a question.
Thanks for the talk. I got one question about the repository. Is there any open source repository with
No,
policies?
it's not.
Like
it's a very trivial.
Check out what
no,
what
it's super easy. It's just Nginx which just serves the star GZ file.
Yeah, but is there any open source repository that people put own ideas like, okay, I would like to have, for example, namespaces into the issue, as you said?
Oh, this one. Yes,
Something like that.
Yes and no. So I've seen a repository which name might mean that this is the purpose of it, but it's empty. Empty yet, but I think it's the right way, and I would expect soon to have these policies and constraint templates being available, because the rules can be shared.
Okay, do you have some more questions? Okay, and if not, then let's thank you.
Thank you much.